Good morning. It's April 4th, and this is your daily brief in science. Here's everything you need to know. Bonobos, the great apes native to the Republic of Congo, are showcasing a remarkable range of vocalizations, including peeps, hoots, yelps, grunts, and whistles. In a groundbreaking study, researchers have compiled a database of over 700 bonobo calls, applying linguistic methods to create a comprehensive bonobo dictionary that catalogs the meanings of these vocalizations. This extensive research involved significant fieldwork, with early mornings and considerable travel to bonobo nests, where calls were recorded throughout the day to capture a diverse array of vocalizations. The study reveals that bonobos can combine these vocalizations in ways that suggest a level of language complexity previously thought to be unique to humans. About half of the recorded bonobo calls were combinations of at least two different call types, indicating potential compositionality. Compositionality refers to the ability to combine elements to create more complex meanings, a feature traditionally considered exclusive to human language. For example, the peep-whistle appears to mean "let's find peace," used to ease social tensions during mating or competitive displays. Another combination, the yelp-grunt, translates to "let's do what I'm doing," encouraging others in activities such as nest building. The research team meticulously documented the context surrounding each call to determine its meaning, creating a semantic cloud of utterance types for analysis. This research provides the first clear evidence of non-trivial syntax in any animal species, marking a significant advancement in comparative and evolutionary linguistics. Published in the journal Science on April 3, 2025, the findings have sparked debate among scholars regarding the implications for understanding language origins. While some researchers praise the study for its innovative approach, others express skepticism, arguing it does not contribute to understanding the evolution of language as it pertains to human communication. A recent study published on April 3, 2025 in the journal Device reveals exciting advancements in solar cell technology utilizing lunar materials. Researchers have made significant progress by melting simulated moon dust to create Moonglass, which, when combined with perovskite, results in a solar cell that can produce up to 100 times more energy per gram than traditional panels. These new solar cells are notable for being lighter, cheaper, and more resistant to radiation compared to conventional solar panels. The Moonglass solar cells demonstrate remarkable stability against radiation, outperforming Earth-made versions by preventing efficiency loss due to browning. The creation process for Moonglass is straightforward, requiring only concentrated sunlight to melt lunar regolith. This simplicity in manufacturing eliminates the need for complex purification processes. Plans are already in motion for a small-scale experiment on the Moon to test these solar cells under real lunar conditions, which could be crucial for future lunar settlements. This innovation presents a low-cost solution for powering potential lunar bases, addressing energy requirements for manned missions and other applications that utilize moon dust. The study emphasizes the efficiency of these solar cells in converting sunlight into energy while maintaining resistance to radiation damage, making them suitable for the harsh conditions of the lunar environment. Perovskite solar cells are particularly favored for their lightweight and thin manufacturing capabilities, beneficial for transportation to the Moon. However, challenges persist for real-world application, as lower gravity may affect moonglass formation and extreme temperature fluctuations pose additional hurdles. The long-term vision includes expanding this technology to utilize regolith from other celestial bodies, such as Mars, to enhance energy generation in space further. Initial testing has shown a 10% efficiency for these solar cells, with the potential to reach 23% by optimizing the moonglass composition for improved light transmission. Researchers at the University of Illinois Urbana-Champaign have made a significant advancement in the fight against leukemia. They've developed DNA aptamers that specifically target leukemia stem cells, which could enhance treatment efficacy and reduce relapse rates. Led by bioengineering and chemistry professor Xing Wang, the study detailing these findings was published in the journal Advanced Functional Materials on April 3, 2025. Leukemia stem cells pose a unique challenge in treatment due to their ability to circulate throughout the body and hide in the bone marrow, which contributes to high relapse rates. The newly developed aptamers utilize a dual targeting approach, effectively delivering chemotherapy drugs while also being toxic to leukemia stem cells, addressing the issue of treatment resistance. In their research, the aptamers were paired with the chemotherapy drug daunorubicin, enhancing its delivery into cancer cells. This is particularly important as daunorubicin typically struggles to cross cell membranes alone. In live mouse models, the combination of aptamer drug conjugates resulted in significant tumor reduction and improved survivability, using a dose 10 times smaller than the clinical standard, with no off-target effects observed. Laboratory tests showed that the aptamer alone was able to reduce cancer cells by 40% within 72 hours, while the drug-loaded aptamers achieved effective results at doses 500 times smaller than standard chemotherapy dosages. Looking ahead, the research team plans to identify unique markers for other cancers and develop additional drug-delivering aptamers. This work highlights the critical need to target leukemia stem cells to prevent relapse and secondary cancers, as emphasized by postdoctoral researcher Abhishek Dwivedi. The innovative approach not only improves drug delivery, but also enhances the precision of leukemia treatments, potentially transforming patient outcomes. NASA's Perseverance Mars rover has recently captured extraordinary footage of a larger dust devil consuming a smaller one while exploring the Jezero crater. The larger dust devil measured about 210 feet wide, comparable to the wingspan of a 747 airplane, while the smaller one was approximately 16 feet wide. This remarkable observation occurred from about 0.6 miles away at a location called Witch Hazel Hill on January 25, 2025. Dust devils on Mars are typically short-lived, lasting around 10 minutes, and the larger dust devil likely met a similar fate shortly after the video was recorded. Mark Lemon, a scientist involved with the Perseverance mission, explained that dust devils can either merge or destroy one another upon encountering, depending on their strength. Atmospheric scientist Priya Patel noted that the thin Martian atmosphere would make the experience of being near a dust devil feel like a light gust of wind. Studying dust devils is crucial for understanding Martian weather patterns, as they indicate atmospheric conditions and contribute significantly to the dust present in the Martian atmosphere. A key goal of the Perseverance mission is to search for signs of ancient microbial life while also caching samples for future return to Earth as part of the Mars Sample Return Program. The rover's imaging experiment aimed to study the Martian atmosphere, contributing to a deeper understanding of its dynamics. NASA's exploration of dust devils dates back to the 1970s, with earlier missions like Viking and Pathfinder documenting these phenomena. Since landing in early 2021, Perseverance has frequently observed dust devils, including a notable event in September 2021, when it recorded the sounds of a dust devil. In addition to dust devils, Perseverance has made significant discoveries, including unique rock formations with spherules, which NASA plans to analyze in future missions. Engineers at a University of Bristol spin-out company have developed a groundbreaking technology that utilizes acoustic waves to move living cells, eliminating the need for bulky lab equipment. This innovative approach leverages vibrations created by acoustic waves to manipulate small objects like cells, allowing them to dance around their container for observation. The acoustic levitation technology enables complex tasks, such as cell population expansion, to be performed on a compact benchtop device. This significantly reduces space and resource requirements in laboratories, making it a game-changer for researchers. The implications of this technology could greatly enhance the discovery of new medicines and facilitate personalized medicine screening in clinical settings. Dr. Luke Cox, the CEO of the startup Impulsonics, presented this concept in an article published in Science on April 3, 2025, as part of the Bioinnovation Institute and Science Prize for Innovation. In his prize essay, Dr. Cox detailed his journey and the potential impact of this technology on biomedical research. Originating from a student project focused on levitating diamonds, this technology has evolved into a compact device that automates essential biomedical tasks and accelerates drug discovery. Traditionally, drug development has relied on extensive manual cell growth, which is labor-intensive and often unreliable, hindering the progress of novel drug discovery. The potential applications of this technology extend across the biotechnology field, promising advancements in the pharmaceutical and healthcare industries wherever cell manipulation is required. Professor Bruce Drinkwater, a co-founder of Impulsonics, noted that the device occupies only half the space of a standard lab bench while producing high-quality data quickly, which is essential for biomedical research. By automating cell movement, this device opens up new possibilities for personalized medicine screening, enabling rapid testing of multiple drugs to identify the most effective treatments for patients. The technology can perform complex biomedical tasks, such as expanding cell populations, which could significantly accelerate the screening process for new drugs targeting diseases like cancer and Alzheimer's. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.